We are in case 1.3. In this case, we are going to differentiating power of trig functions. Now, what's something now? When we talk about power of trig functions, we are talking about this type of function. Look at cos squared x, sine raised power 4 x, and something like that. So, how do we manage that? Let's take number one. If we have that y equals to cos squared x, this is also written as cos x all squared. If you're seeing this as this, it makes more sense. Why? Because it tells you purely that this can be solved using chain rule. It can be solved using chain rule. Then in chain rule, we used to say whatever is in the bracket is the u. And the y dx for it becomes the y du times the u dx. Okay, so let's apply that here. I will say let u equals to cos x, so that du over dx becomes minus sine x. At this point, the question changes. If this becomes u, that means y becomes u raised power 2. Y equals to u raised power 2. Then the y over the u becomes 2u. So remember that my dy over my dx should give me the y over dx times du over dx. My dy dx is 2u. While my du dx is minus sine u. So here I'm going to be having 2u times minus sine x. So 2, what is u? Remember that u is equals to cos x into minus sine x, which will properly be written as minus 2 cos x sine x. Final answer. So if you observe what we have done there, if you differentiate cos square x, you are going to be having minus 2 cos x sine x. We go to the second question there. The second question there is saying y is equals to x sine 4x. If that be the case, then the leading algebraic sign here is product. Do you get that? Because it's x times sine 4x. So I'm going to be using my dy over dx here will look like u dv plus v du. Here my u and this is my v. So I'm going to say u is equals to x, so that du over dx is 1. V is equals to sine x all raised to power what? 4. Now, my dv now, I'm going to use what we call inside-outside rule here. Otherwise, I will solve this the way I did for this. That is the general way. But inside-outside rule also makes things easier. You can check that up in our lesson 1. So, I drop 4. I write my sine x. 4 minus 1, 3. Then the final answer becomes differentiate sine x. I have cos x. Use it to multiply 4. I have 4 cos x, then sine cubed x. So if I differentiate sine x raised to power 4, I will have 4 cos x sine cubed x. So I have my dv, I have my u, I have my du. So I'm going to conclude by saying my dy over dx becomes u, which is 1. My u is x into dv, 4 cos x sine cube x. 4 cos x sine cubed x. Then that is u dv plus v du. V is sine 4x into du. Du is 1. So this becomes my u dv plus v du. Then this becomes 4x cos x sine cube x plus sine 4x. This becomes the answer we are looking for. So if I differentiate this, I'm going to be having this. Master, know that this is the real reason why we are here. But then, this is the question. The leading algebraic sign here is product. So we have to solve it using product rule. Quickly, we go to question number 3. Under question number 3, we are going to be, they say that y equals to cot squared x cubed. At this point, this is the same thing as cot x cubed all raised to power 2. So the same thing I'm going to be doing, I will say let u equals to cot x cubed. Then my du over the x. I'm going to use one of the shortcuts we have used earlier in this class. If I differentiate x cubed, I will have what? If I differentiate x cubed, I will have 3x squared. Then if I differentiate cot, I will have minus cosec. Go back to the table. Let me be very sure. Go back to the table. If we go back to your table, you will see that. I think that table. Okay. So if you differentiate cot x, you can see that it will give you minus cosec squared x. So this will become minus cosec. Hope you remember. Minus cosec squared. Then bring back x cubed. So that finally this becomes minus 3x squared cosec squared x cubed. Okay. So if I differentiate this, I will have this. Please don't get confused. Remember, you can do it in a normal way. Call x cubed your u. Get your du dx. Then the question changes to cot u. Then you get your dy du. When you multiply your dy du times your du dx, you also arrive here. Okay? So let u be equals to this. Then my du dx will give me this. Then the question now, y becomes u raised to power 2. So that my dy over du becomes 2u. Now, in conclusion, the y over dx is equals to the y du times du over what? Dx. At this point, what is my dy du? Dy du is 2u. 2 into u. What is my u? Cot x cubed. Cot x cubed plus, okay, times du dx. Du dx. The whole of this. Wash again. Dy du is 2u. 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 Okay. Then du dx. The y du, okay. Du dx is this. So times minus 3 x squared into, okay, minus 3x squared cosec squared x cubed. I think so. At this point, when we multiply this by this, we take the numbers. 2 times 3 will give me minus 6. Minus 6. Then x squared. I have cot x cubed cosec squared x squared. That becomes my final answer. Watch the way I did this. 2 times minus 3x squared gives me minus 6x squared. Then this was brought down here. This was brought down here. Hence, if I differentiate this, I'm going to be having this. Watch out the way we differentiate power of trig functions. we are going to conclude with this. This is not under here, but I have to bring it here as a miscellaneous question so that we can see what really happened there. Okay, quickly we attack that. Okay, I would like to leave y equals to x sine x over x plus sine x. This, I will leave it as assignment for you to try. You know you are going, the leading algebraic sign here is division. Division. So you do this, this becomes your u, this becomes your v. By the time you finish solving this, I want to see your answer in the comment section. I want to see your answer in the comment section. So I will leave us with this to try. So this brings us to the end of case 1.3. And we'll be going into case 1.4, which is the last case for case 1 proper. Okay, case 1.4, which is the last case for case 1 proper. And if that is the last case for case 1 proper, that means we are leaving differentiation of trig function to another type of function. So try and do this and let me see your answer in the comment section, and I'll be glad to see you following. So please don't forget to subscribe so that once these lessons are uploaded, you are following. Like I used to say, follow me up. Okay, before us is our case 1.4. In case 1.4 now, still on lesson 2, we are going to be doing differentiation of inverse of trigonometry function. Now, if you observe the board, you will see what I mean by inverse. In case 1.3, we dealt with power of trig functions. Now we are dealing with inverse. Now, look at the board. Now I have a table here. Sine inverse of x is equals to this. Cos inverse of x is equals to this. Tan inverse of x is equals to this. Cot inverse of x is equals to this. Sec inverse of x is equals to this. And cosec inverse of x is equals to this. Just like we did in our case 1.3, I'm going to do the same in case 1.4. In that I'm going to prove why from number 1 to number 6, why they have this derivative. Now, one thing I want us to understand here is in this case 1.3 that it is the same. It is the same for every solving. The solving system is the same. So if you can master one, you master all. But then, on a serious note, you need to cram these things. On a serious note, you need to cram these things. They are not difficult to have in your head. Now, what's something now? If I differentiate sine inverse of x, I have 1 over root of 1 minus x squared. Now, look at cos inverse of x. The difference between this one and this one is just a minus 1. This is plus 1, this is minus 1. So sine and cos goes together. Now, coming to tan, if I differentiate tan inverse of x, I have 1 over 1 plus x squared. Then look at cot inverse of x is minus that differ them. So if I know this one, I know this one. If I know this one, I already know this one. Now look at sec and cosec. If I differentiate sec inverse of x, I have this. Whereas cosec of it will give me minus 1 over the same thing. You see that? So they are the same. So it's not difficult to have. So we are going to go into some examples and drive the point home. And I think that will be the end for case 1.4. Then we'll be saying welcome to case 2 of differentiation of lesson 2. From what we see above, we're going to do the whole of this. Okay. I want to do sine inverse of x. I want to do sine inverse of x. So what I'm going to have here follow. This question is going to be written like this. Y equals to x over sine. See how I started? Y equals to x over sine. Then I cross multiply. I'm going to be having x is equals to sine y. X is equals to sine y. I'll have the x, the y. So if I differentiate, I have the x over the y. If I differentiate sine y, I have cos y. Now, inverse of the x, the y, which will give me the y, the x. So the y over the x will give me 1 over cos y. So remember what I've done from here to here. What I'm going to do now is I'm going to find the exact value for cos y. How do I get that? I will say but cos squared y plus sine squared y is equals to 1. So that cos squared y will give me 1 minus sine squared y. Okay? So that cos y alone will be root of 1 minus sine squared y. So at this point, anywhere I see cos y, I can put this. So I will repeat the value I have. The y over the x becomes 1 over, instead of writing cos y now, I will write root of 1 minus sine squared y. Now at this point now, watch now, x is equals to sine y. So anywhere I see sine y, I can write x. So if I have sine squared y, that means it is x squared. So therefore, but x equals to sine y, so that x squared equals to sine squared y. Therefore, the y over the x becomes 1 over root of 1 minus x squared. And that becomes my final answer. So it is clear now that if I differentiate sine x, sine inverse of x, I will have 1 over root of minus squared y. Okay, that is that. We go to the next one. Now, I haven't seen the way I did for sine inverse of x. I believe you can do for cos inverse of x. You are still going to use the same exact value. Okay, let's see something about that. Y equals to cos inverse of x. So I will have that y becomes x over cos. Cross multiply, I will have this. So at this point, I'm going to be having the x over the y equals to, if I differentiate cos y, I'll have minus sine y. So upside down will be dy over dx to give me 1 minus 1 over sine y. So I'm going to look for exact value for sine y. Remember, for us to get exact value, we said that sine square x, okay, y plus cos square y is equals to 1. So that sine squared y will give me 1 minus cos squared y. So that my sine y becomes root of 1 minus cos squared y. So anyway I see sine y, I can put this. Therefore, my dy over dx becomes minus 1 over root of 1 minus cos squared y. That's the game. Now, remember that x cos y is equals to x. So I'm going to be having the y over the x equals to minus 1 over root of 1 minus x squared. And that is what we have got. Remember, in the first one, there was no minus here, but in this one, there's minus here. So we are able to solve for cos inverse of x and cos inverse of y. So we head to cos tan inverse of x. Okay, we'll go to question number 3 now. If we have that y equals to tan inverse of x, so this is just like saying y equals to x over tan. So just the same way I have x equals to tan y, so that the x over the y, if I differentiate tan y, I have sec square y. Sec square y. So when I have this, this becomes the y over the x becomes 1 over sec square y. Then getting the exact value for sec square y, remember, look at this. Sec square y minus tan square y is equals to 1. So that sec square y is equals to 1 plus tan square y. So if I have this, so anywhere I see sec square y, I can put 1 plus tan square y. So my dy over dx becomes 1 over 1 plus tan square y. But then tan y is x, so I can put x here. The y over the x becomes 1 over 1 plus x squared. And that becomes my final answer for question number 3. So we move to question number 4. Okay, now having on the board cot inverse of x. This can be written as y equals to x over cot. So that my x becomes cot y. Then I have the x over the y to be 1 over, if I differentiate cot y, I'm going to be having minus cosec square y, minus cosec square y. I'm going to now be able to do that. My dy over dx will give me minus 1 now over cosec square y. Now, I'm going to find the exact value for cosec square y. Pick it from here, cosec square. So I have that cosec square y minus cot square y is equals to 1. So that cosec square y becomes 1 plus cot square y. Haven't got this, so I have my dy over dx to be equals to minus 1 over 1 plus cot square y. But then x is equal to cos y, so I'm going to have my dy over dx to be equals to minus 1 over 1 plus what? X squared. You see, so if you differentiate cot inverse of x, you are going to be having minus 1 over 1 plus squared x. So we move to the last one, which is second to the last before the last, sec inverse of x. Now we are left with question number 5. We have that y equals to sec inverse of x. Okay, the same way we have y equals to x over sec. If I cross multiply, I have sec y. So I'm going to have my dx over the y to be, if I differentiate sec y, I'm going to have, if I differentiate sec y, I'm going to have sec y tan y. I'm going to have sec y tan y. So I'm going to find exact value for sec y tan y. Now, we already know that sec y is x. We already know that sec y is x. So if sec y is equals to x, then exact value for tan y, from here we have sec square y minus tan square y is equals to 1, so that tan square y is equals to sec square y minus 1. Then tan y is equals to root of sec square y minus 1. But sec square y, sec y is x, so tan y becomes root of x squared minus 1. Therefore, now my dy dx becomes, remember that here we are supposed to have my dy over dx first of all to be 1 over sec y tan y. So that here I'm going to be having 1 over sec y is x, then tan y is root of x squared minus 1. And that becomes inverse of sec inverse of x. So we are left with cos inverse of x. I would like to leave that as students to do. Try and do cos inverse of x following these methods, and then let us see our answer in the comment section. Okay, so we're going to make we're going to do some few examples again, and then we call this a day. Okay, without wasting much time, we want to do these examples we have on the board. We're going to be very quick with this. Sine inverse of 2x. Now, I might not be following the normal method. I'm going to teach you a very short method. Remember, I told us that you need to cram the table. Okay, see what I'm going to do here now. If I'm asked to find sine inverse of x, I will say if sine inverse of x is 1 over root of 1 plus x squared, then sine inverse of 2x will become, watch now. This one is here because if you differentiate x, you have 1. This one is here because if you differentiate x, you have 1. Then this function is what you are seeing here, then squared. So I'm going to do the same to this. Differentiate 2x, I have 2 over root of 1 plus. The function here is 2x. I write 2x and squared it. So my final answer becomes, my dy over dx becomes 2 over root of 1 plus 4x squared. Final answer. I believe that was very fast and enjoyable. Okay, let's look at number 2. For those that have not gotten it, watch now. We are given tan inverse of x squared to find. I will say, but if tan inverse of x is 1 over 1 plus x squared, remember that? Then tan inverse of x squared becomes, if I differentiate x squared, I will have 2x. Then 1 plus, the function here is x squared all squared. So that my dy over dx becomes 2x over 1 plus x to the power 4. Final answer. I believe that is very, very clear. You can repeat it. You can rewind the video to see what exactly I've done there. Coming to this one, cot inverse of 4x squared. I have, if cos inverse of x originally is minus 1 over root of 1 plus x squared, then cos inverse of 4x squared will become, there's this minus is steady here, then differentiate 4x squared, we have 8x over the same root of 1 plus, the whole of the function here is 4x squared all squared. So that my dy over dx becomes minus 8x over root of 1 plus, this is 16 now, x is 4. Final answer. I believe this is not magic. But I think my method is faster. So I do the last one, which is sec inverse of 4x. Sec inverse of 4x. I will say sec inverse of x on its own is 1 over x root x squared minus 1. So, therefore, sec inverse of 4x will give me, I differentiate 4x, I have 4 over, now, this x is the function here. So the function here is 4x. 4x root of, are you there? 4x all squared minus 1. So that my dy over dx becomes 4 over 4x root of 16x squared, are you there? Minus what? 1. And that is the final answer. Now, at this point, we are through with differentiation of inverse of trig function. So everything I asked us to master here, you master it. Remember, it took us very short time to solve all this. Why? Because we have mastered the table. If you have not mastered the table, you are going to use another method which we call the chain rule, and which might take you time, or you use the direct method, which from the first principle, the way I did the original inverse x. But then this method I see is very fast and reliable. trusted everywhere. So thank you for following me up in the lesson 2 case 1. I meet you up in lesson 2 case 2, and that will be differentiation of exponential functions. Please, the assignments I give, ensure to put your answers at the comment section, and don't forget to subscribe to this channel for you to follow up the class. I want to see those that are following up the class so that I will know how to improve the class. Thank you and God bless you. Don't forget to share on Facebook. Don't forget to share on Twitter or whatever social media you are. Invite people to join this class. Let's do this mass 112 together, and God will bless you.